All right, so when working with rational functions, there's obviously a few things that we can do. I'm going to go through the 6 steps, which is the most I would ask you for. Usually when we start working with the rational function, if it factors, we'll do some factoring. Okay, we will typically need it at some point. So in this case, the numerator clearly does not factor. Denominator becomes 2x minus 1, x plus 3. Okay, but again, remember at this point we'd just be factoring. There's no cancellation to do here anyway, but if there was some cancellation to do, we wouldn't do it yet. All right, so first part is domain. And we can't allow for 0 denominators, so x cannot be any number that results in a 0 denominator. So in our case, 2x minus 1 would give us x can't be a half. X plus 3 means x can't be negative 3. Okay, so we have a graph everywhere but at 1/2 and negative 3. Okay, which leads us to our second question, which is to find all the vertical asymptotes or holes. Okay, remember for rational functions, at any x value, not in the domain, the next question is, okay, what is happening there? There's not a point there because it's not in the domain. So is there a vertical asymptote or a hole? So it's a natural question to ask after you find the numbers that are not in the domain. So we're going to check each of these. Now, how do we check them? Well, again, we don't want to plug in necessarily, right? Because we know if you plug in either one of these, we get a 0 denominator. Okay, and so this is where if we have any cancellation, we would do that. Okay, I don't. Okay, so there's no cancellation to do here. So again, remember that I would typically call that f hat, but I don't have that here. So we take f at 1/2. Okay, now again, we already know we get a 0 denominator. That's why it's not in the domain. But if you plug 1/2 into the top, we get 3/2. Okay, this is undefined. Okay, any 0 denominator is always undefined. That's why x equal to 1/2 is not in the denominator. But if it turns out, like it does here, we have a non-zero number over 0, so in this case 3/2 over 0, or if we wind up with 2 over 0 or negative 8 over 0, any non-zero number over 0 means that this in fact turns out to be a vertical asymptote. Okay, and then we just check at our other one. What happens if we plug in negative 3? Again, denominator is no problem. The whole point is that it was not in the domain because it gave a 0 denominator. A little bit more interesting is what happens when you plug negative 3 into the top. Okay, so again, we get negative 2 over 0. It is undefined. That's why it's negative 3 is not in our domain. But because it turned out to be a non-zero number over 0, then we know x equal to negative 3 is a vertical asymptote. Okay. All right. So again, the first 2 steps are find out which numbers are not in the domain, and then tell me at each of those 2 numbers, do you have a vertical asymptote or a hole? So in our case, we had 2 numbers not in the domain. Both turned out to be vertical asymptotes. Okay. Part C, this is kind of a different question. Okay. We're looking for, does our graph have a horizontal or oblique asymptote? Or maybe it'll have neither. Okay. This has nothing to do with the domain. We're kind of done with part A and B here. Okay. So remember, horizontal and oblique asymptotes are the long-term behavior. And again, that's determined by the leading coefficients of the numerator and denominator. So we have a degree 1 on top, we have degree 2 on bottom. So in the long run, the bottom will grow much faster. Anytime the bottom grows faster because it's of higher degree, that means the whole fraction will collapse to 0. This denominator will get much bigger, much faster. So if the degree on the bottom is bigger than the degree of the numerator, the fraction will collapse towards 0 in the long run. So the outputs will continue to get closer and closer to 0. Okay, so that's our horizontal asymptote. And again, keep in mind for the graph, as x approaches infinity or as x approaches negative infinity, y is going to approach 0. Part D, we would do only if we have a horizontal or oblique. So we want to know, just as a way to kind of look at the graph or get a few more points on the graph, does our graph cross this horizontal asymptote? Okay, keep in mind back here, we never cross vertical asymptotes. X cannot be a half, x can't be negative 3. The numbers are not in our domain. But for horizontal, we have a horizontal asymptote at y equal to 0. The graph can cross it. Again, at the ends Way over here at plus and minus infinity, well, no, we approach 0, but we could cross 0 at other times. Okay, so again, remember, you're just trying to solve, does this function, which is x plus 1 over 2x squared plus 5x minus 3, does it ever equal 0, which is our asymptote? Okay, well, remember, a fraction can be 0 only when the numerator is 0. And so we get at x equal to -1. Okay, so this point, -1, comma, y is 0, is a point on our graph. It's a point where the graph crosses the horizontal asymptote. Okay. And then one more piece of information we would like to get, again, just a few more points, which are our intercepts. So remember, x-intercept is where the function equals 0. So we solve f of x equal to 0. Okay. Now, in fact, we already did this in part D, and we found out that -1, 0 was our intercept. Y-intercept, y-intercept is we have to plug in 0. So remember, this is not a solving, this is just an evaluate. F at 0. So if you plug in 0 all the way back in your original, remember all the x's go to 0. So you just get 1 over -3. So we have the point 0, comma, -1/3. Okay. And now we'll just graph this. All right, so we just put all our information on here. We have 2 vertical asymptotes. Let me get a little bit of scale here. So we put in our vertical asymptote here at x equal to 1/2. Again, this is not really part of the graph, it's one of the guidelines for the graph, and back here at x equal to -3. Okay, we have another asymptote at y equal to 0, which coincides with the x-axis. Okay, so our graph begins over here, ends over here. Yeah, remember, when you run into asymptotes, you either go up or go down. Okay. We have a few points. We have the point -1, 0. We have the point 0, -1/3. Okay. And so now it's just a question of where is our graph. Okay, now in between here, well, let's start on the left. So again, you can use your calculator to do this, or you can just try out a point. But again, your graph either has to be up here, or it's going to be down here. It can't cross the axis. Remember, we already found all our x-intercepts. We only have 1. So your graph is either starting just above the x-axis and heading up, or it's starting just below the x-axis and heading down. So you could plug in a point, maybe plug in -4, -5. You will find out that it's negative, and so we have this picture. Okay. Similarly here, we know since we're down here, we have to continue down. You can't go back up because you can't cross the x-axis. So we know we're coming down here. Okay. It's a little bit of a question which way we should go over here, but just plug in -2, you find out you get a positive number. So you're above the axis. Okay, remember, when you run into asymptotes, you have to shoot up or shoot down. Okay. Same thing on the right side. You're either completely above the x-axis or below. Again, just plug in 2 or plug in 3. It turns out to be a positive number. So you know you have to be above. And then we get a pretty good graph of our function.